Hello everyone. So the problem which we'll be solving today is the third problem of this contest. The problem is called count subarrays with cost less than or equal to k. So first let's read the problem statement. The problem statement says that you are given an integer nums and an integer k. For any subarray, nums L to R is define its cost can be defined as maximum of that nums of L to R minus minimum of nums L to R into R minus L plus 1, right? So you need to return an integer denoting the number of subarrays of nums whose cost is less than equal to k. Right, let's look at this example. So if nums is 132 and k is equal to 4, so we will consider all subarrays of nums. What are the subarrays? 1 can be a subarray, 1 3 can be a subarray, 1 3 2 can be a subarray, then 3 can be a subarray, 3 2 can be a subarray, and then only 2 can be a subarray, right? So these were the all possible 6 subarrays which can be formed, right? So if you look at nums of 0 to 0, it is 1, so cost is 1, maximum is 1, minimum is 1, so it will be ultimately 1 minus 1 into 1, which will be 0. Nums of 1 to 0 to 1 means this range. In that cost will be maximum is 3, minimum is 1, so 3 minus 1 into 2, which is 4, right? Nums of 0 to 2, in this what is the maximum? Maximum is 3, minimum is 1, and the length is 3, so it will be 3 2 into 3, which is 6. Then from 3 to 3, this will be 0 because first only single element, so 3 minus 3 will be 0. And then this subarray, what is the maximum, what is the minimum? You can do the diagram. Maximum will be 3, minimum will be 2, and length is 2, so 2 into 1, which will be 2, and the last subarray is 2 minus 2 into 1, which is 0. So I hope the test case and the problem statement is clear to you, right? So let's look at how things will work in this, right? So let's first look at the constraints as well, right? There are few test cases more given to you. You can look out at those. Let's look at the constraints which is given to us. The constraints is nums dot length is 1e5, right? So if n is 1e5, then what is the problem statement asking? What is the expected time complexity from our side? The expected time complexity can be big O of n, or it can be big O of n log n, right? You can't exceed this, right? You need to be in the bound of this range, right? All right, so we need to write a solution. We can't generate all the subarrays because generating all subarrays will take a big O of n square, and if we want to find maximum and minimum in that, it will give us a KV, right? I hope the brute force approach is clear. What is the brute force approach? Let me again define it to you. Let's say the subarray was 1 2 3, right? 1 3 2, right? So we can run a pointer from this point, and I will run from 0 to n, right? So I'm first explaining the brute force, and you should be thorough with these things, that how you can explain these things to anyone. So I will go from 0 to n, and similarly j will go from I to n, right? All the possible permutations, all the possible subarrays, not permutations, will be created by this, right? Let's say 1, then 1 3, then 1 3 2, right? Then 3 3 2, and then 2, right? So ultimately the time complexity of this code, and while doing these, right, you can simply find maximum and minimum on the way, and this will take a time complexity of big O of n square. I hope the brute force of idea is clear to you, right? And as I said, this will fail because our time complexity which asks us to solve this is in big O of n or big O of n log n, right? So what can be the approach, right? Let's look at a test case which I have taken where k is equal to 13, right? Now this test case will clear many things for us, right? Let me change the color. Let's take this one, right? So while we are solving this, right, when we are first on this element, right, we can, what data structure can we use here, right? First this should come to your mind, right, that you want to find the maximum and minimum, right, in the subarrays, right? Whenever there is a problem, I am giving you a brief hint, not type of hint, it is a type of thing which you should remember, that whenever they are saying you to create or let's say count, right, count number of subarrays, right, number of subarrays, right, number of subarrays, then the first thing that should come to your mind is, can sliding window be used here? Sliding window, right? And exactly that will be used in this case, right? How we will use a sliding window, let's look at that as well, right? So let's say our element, first element was 1, right? So we had a 1, right? So, and till now we have not discussed about what data structure could be used in this case, right? Let me give you a hint. It is something related to set, right? Not exactly set, it will be a multi-set. Let's now, let me not hold it back. It will be a multi-set. Now how multi-set will work, why it will work, it is very easy to understand. Let's say we had a 1, right? We can have repetitive elements, right? They have not said anywhere that elements won't repeat, right? Elements can repeat is one thing, right? So that is the reason we won't be using the simple set, right? Because set does not contain duplicate elements, right? All right. So let's say we were on the element 1, right? So what we were doing, 1, we will put it in our multi-set, right? Putting m, I am calling it as ms, right? Ms is the multi-set. Now for this, if you want to find the maximum element in a multi-set, it will be found in big of log n. If you don't know, so any element which is in the multi-set, right, the first element is the topmost element, that will be found in big of n. I think if not maxi, not log n, it can be done in big of 1 also, right? We just need to compute it, right? Let's say the first element is 1 and the second element, let's say for example it is 9, so it will be stored in multi-set like this. So if you want to fetch the first element, it will be 1, and if you want to fetch the last element, it will be 9, right? It is sorted in order, right? So if 1 2 3, then 9 will come, right? So in multi-set this is done, right? So it will be not big of log n, my bad, it will be big of 1 only. So in a multi-set it will be stored like this, right? So if we are having a multi-set, right, and this shows us that we can simply find any element, the maximum element in big of 1, right? Let's say 1 2 3 and let's say 10, right? So if you want to find the minimum, right, so minimum is can be found in big of 1, so minimum is 1, right? And maximum is 10, right? It can be also found in big of n, right? I will show you the code, you will understand how, what is the syntax for it. Let's not discuss about the syntax first, let's first look how that thing is working, right? So let's say we had 1 3 2 4, right? 1 3 2 4, right? So if we were on the first element, right, we will put it in our multi-stack, right, multi-set rather. So it will be 1 will come here, right? We will say what is the minimum element, it will say as 1. What is the maximum element, it is also 1, and k was 13, right? K was 13. So we will say, is this a valid thing? It will say yes, because the cost will be 1 minus 1 0, right? So it is valid, so 1 is a valid subarray, right? Then we move to 3, right? We will push it in our multi-set. Now maximum is 3, minimum is 1, so cost will be 3 minus 1 into 2, right? The length is 2 of this subarray, right? So is this valid? They will say yes, right? So we will again say yes, this is also valid. Now you notice one thing, what can we notice over here, right? The cost which will be ultimately come is 4, right? Now if you look closely into it, now let us take one step more forward, and then I will come back to this step. Let's say we took the second element. So how the multi-set will look like? It will look like 1 2 3, right? It will rearrange itself, right? Whenever you insert an element, multi-set gets arranged itself, and it takes log of n time, right? So it won't cause big of n. So ultimately the time complexity, that the time which we were thinking is saved, right? So when you put 2 in this multi-set, now the minimum is still 1, maximum is still 3, right? Now the answer is cost will be equal to 3 minus 1, and the length is now 3, right? So this is also a valid index, right? Because k was given as 13 to us, not 4. I'm using a different k so that we can understand something, right? Now if you closely observe in this now, if let's say my subarray 1 3 2 was valid, right? If I'm saying my subarray 1, sorry for this, 3 and 2 is valid, right? I'm saying this subarray is valid. right? Then what I can say, if this subarray is valid, then this subarray is also valid, then this subarray is also valid. Why? Because if the leftmost element which we had didn't create any problem to us, then the rightmost element, whichever element we had in this subarray, will also not create a problem. So every time we are, let's say we were on this L and we are on this R, so how many elements will be added to our answer? Answer will be plus equal to R minus L plus 1. Means all the subarrays which are in between these are also a valid one. Means 1 is valid, 1 3 is valid, 1 3 2 is valid, then 3 is valid, 3 2 is valid, right? And 2 is also valid, right? So this was the logic behind this, right? Answer will be equal to R minus L plus 1. Means I'm saying that if this element here is 1, right? And if in multiset they rearrange itself, right? So if this didn't cause us any problem, then in this all elements won't cause us any trouble, right? Let us look at this test case again, which was given to us 132, right? And 132 was causing a trouble for k equal to 4, right? In which case, let's say it is causing a trouble, let's see, it is causing a trouble in 0 to 2, right? So if this is valid, you tell me, if 1 3 is valid, can't I just simply say that 3 will also be valid, right? That was my claim, right? My claim here was, if 1 3 was valid, then all the subarrays in between will also be valid. And how can we do that? By simply doing answer plus equal to R minus L plus 1. I hope this logic is clear to you, right? Why are we doing this, right? Let's say we had 3 over here, right? I'm just rearranging the elements 3 to 1, right? Now let's keep 1 in between, right? And now if I'm saying that if this subarray, let's say, is valid to us, right, then all the subarrays which are in between these will also be valid. Getting my point? So this was the logic behind the problem statement, right? The problem, right? Now let's look at the code, right? So what I'm doing is, we are simply traversing, we created a multiset ms, right? And answer equal to 0, left is on the 0, right is on the 0, right? While right is less than n, right? Means this pointer, right? Let's say my array was 132, right? 132, right? So left will be pointing at this initially, right is also at this, right? What I'm saying is, multiset dot insert nums of right. So multiset will have 1, right? And then we will find the maxi and mini, right? And what I'm saying is, this while loop, let's first ignore this while loop, right? Let's first ignore this while loop. What I'm saying is, while not let's ignore it, let's say first say, if my maxi minus mini, that is the cost into right minus left plus 1, if that is greater than k, right? Means if I'm saying this window, right, let's say this window was greater, 132 was greater for k equal to 4, right? So 132 is causing an issue, then definitely you should move this pointer from this point to another point. Means you should move forward, because all the subarrays which could be possible, you have added it into your answer already, right? So you need to move a bit forward. Now left pointer will move from this point to further point, means you will do a left plus plus, right? So while this value is greater than k, right, you will first erase the left pointer, right? You do a left plus plus, right? And meanwhile you will find the maximum element which is there present, the minimum element which is present in your array, a multiset, right? And your answer is simply right minus left plus 1. Let's quickly do a dry run on this, right? The code is not very hard, right? We just use a multiset, and if you understood why we use the multiset, because to find the maximum and the minimum in the given array, you don't need to create anything, any priority queue or min priority queue or max priority queue, and simply use multiset and find the minimum and maximum using this line, right? Multiset dot r begin means from reverse side you will find the first element from last from reverse side, and minimum is just the first element from the top. So this is how multiset works, right? And if it fails, you will simply remove the pointer, right? Let's say we had 132, right? So 1 was valid, I'm not taking this again. 1 3 was valid, 1 3 was valid, yes, 1 3 was also valid for k equal to 4, right? Because 1 3 will give you 3 minus 1 into 2, right? So this is also valid. If I'm not wrong, it is 4, right? Now when you took this array, now till this point, what will be my answer? Let's look at answer, how answer changes. So in the first step, the answer is, what is the answer? For 1, the answer is r minus l plus 1, right? Which is 1 0 minus 0, r will be 0, l will be 0, so 0 minus 0 plus 1, which is 1, right? You will move this pointer to this point. Now r is here, l is here, right? Now how much answer will be added? In the second step, answer will be r, which is 1 minus 0 plus 1, which is 2, means now answer will be 3. Means it is saying that at this point, at 1 3, right, there are 3 subarrays which are valid. Can you tell me what are the subarrays? 1 is a subarray, 1 3 is a subarray, and 3 is also a subarray. So this is how this thing works, right? This is how the sliding window approach works for us, right? So I hope this point is clear. Now let's move to, when we move this r to here, right? What is our cost? Our cost will be equal to, maximum is 3 minus 1 into length is 3, right? So 2 minus 2 into 3 6, right? So cost is 6, which is greater than k. So if your window, this window gets failed on any k, then you start shrinking the window, right? Now you will, now your l pointer will move to this point, right, which was 3, right? So 3 2, right? And now you will erase this from multiset. 1 will be erased from the multiset as well. So we can simply find any element in multiset in big of log n. If you didn't know this, so any element will be found in the multiset in big of log n. So 1 can be found in log n and erased as well. So 1 2 3, 1 gets erased. Now we again check, is this a valid? So minimum will be this, maximum will be this, and the answer will be 2 3 minus 2, and the length is r minus l. What is l? L came to this point, right? So r minus l is nothing but 1 0 1 2. So 2 minus 1 1 plus 1, right? So is this valid? It says 1 into 2, right? So yes, it is valid. You can take this element. So we will say this subarray is also valid, right? And we will do answer plus equal to r minus l, which is 2, right? So again two elements are added. What are the 2 elements which are added? The elements which will be added at this moment was 3 comma 2 and a 2, right? So this is how the window works for us, right? I hope the problem statement, the code is clear to you. I will add the code in the comment section as well. And we are simply doing answer plus equal to right minus left plus 1, and we are incrementing our right as well, and we are returning whatever our answer is. So what is the time complexity? The time complexity for this code is nothing but big O of log n into log n, right? Because we can traverse on the whole array, right? The right pointer which we had over here, right? This pointer can move across the whole array, and the left pointer is moving, right? So that won't cost us a big extra time, right? It is not causing big of n, and for searching an element, it is taking log n. So it is ultimately big of n log n. So I hope the logic is clear to you, and if I helped you, please do subscribe to us, and leave any comments. If you had any doubts, I will try to help you out. Thank you for watching.